This is another important topic in OSPF. Network types. You see, when we have serial wire, this is how we draw serial wire. We draw a zigzag line, and we also call it as band link. Serial wire band link. The default encapsulation type. What? Okay. The default encapsulation type in Cisco is HDLC. This is the layer 3 protocol, sorry, layer 2 protocol for layer 2 encapsulation. And there is another protocol which is PPP. Every vendor has got this PPP on serial link except Cisco. Cisco has got Cisco's own WAN protocol. And when traffic passes through the serial link, we call it as circuit switching. You might have heard in CCNA. Circuit switching. Circuit switching. You may have HTLC or PPP, but it should be same on both sides. If you are having PPP on left, it needs to be same on R2 also. Can't have one side with HTLC and another side with PPP. That is not the way it works. Secondly, the Ethernet wire between two switches, sorry, routers, you have Ethernet wire. So the protocol here is Ethernet. The speed may vary 10 gig, 20 gig, 10 meg, 100 meg, depends. We call it as Ethernet switching. This is circuit switching, this is Ethernet switching. Now, in circuit switching, when you run OSPF, the network type will be called as point to point. Point to point. That's the network type. Network type. OSPF network type. See, this is point to point protocol. I'm not talking about this protocol. I'm talking about OSPF network type if OSPF runs on circuit switching. If OSPF runs on circuit switching, it is called as point to point network type OSPF. If OSPF runs on Ethernet switching, then the network type is called as broadcast. Broadcast. Network type broadcast. In circuit switching, there will not be any DR, BDR because it's a circuit, only two ends. Only two ends for a circuit. But for Ethernet, it is not two end. If you connect a switch here, then it will get more ends. There will be DR, BDR needed when you have multiple device, no? There will be a DR, BDR necessary for, there is a necessity for DR, BDR. If you don't have DR, BDR, we learned that there will be duplication of update, which will end up in loop. So whether we We have more than two router or not. Whether you have two router or 20 router. This is called as broadcast network type because you are using Ethernet. If it is broadcast network type, there is going to be DR, BDR, and DR other. In point to point, no DR, no BDR. This too, you are well aware of. You have seen this. We even did lab. We have another 5 types. This too you know very well. We have another 5 network types, which we are going to cover in this chapter. Now, do you have any question on this too? Okay. In serial, the default is HDLC. On Cisco devices, the default is Cisco. No, sorry, default is Cisco proprietary encapsulation protocol called HDLC. But if your router R1 is non-Cisco and R2 is Cisco, then you need to change that HDLC into PPP on R2. No, non-Cisco, you already have PPP. Assume R1 is non-Cisco. You already have PPP, but the Cisco switch only will have HDLC. Yeah. So this you go and change to PPP. Right. I'll show you how to do those things when we go to the lab. Now, this too you are very much familiar, right? Let's go to the other 5 types. I just said circuit switching, Ethernet switching. There is also packet switching. Packet switching protocol in layer 2. Ethernet switching is Ethernet protocol. Circuit switching is PPP or HDLC. Now, what is this packet switching? If you will be using any protocol like frame relay, or ATM, or X.25, these are all very old ASPER network, oldest protocol, at least 25 years before this was popular. Like last 18 years I'm teaching. I was teaching frame relay in my beginning days. After that, no one cares. It got removed from the syllabus, and and no one deploys frame relay anymore. The reason is MPLS. That label switching. This is packet switching. That is label switching. So after label switching has come, this packet switching got faded, removed. No one goes for this. Because you need special devices to transport packet over frame relay PVCs. Very costly. So people don't want to have an additional cost buying frame relay switches. So packet switching is no more bad. This is what we call as WAN technology. Or another way to say, the best way to say here in this context is NBMA, non-broadcast multi-access environment. If you are running frame relay or ATM or X.5 instead of Ethernet or PPP or MPLS, if you are running any one of this, then it is non-broadcast multi-access. Non-broadcast multi-access. In non-broadcast multi-access, you have this 5 modes. We saw this one. We saw this one. Now we are here. Non-broadcast multi-access. A network that is interconnected interconnects more than 2 routers, but that has got no broadcast capability. This packet switching is not broadcast capable. This frame relay ATM or X.5, which we call this packet switching, it is not broadcast capable. Frame relay has got something called DLCI, DELC, data link connection identifier, using which it communicates, a kind of unicast. So there is no multicast, no broadcast support here. It's a non-broadcast environment. In non-broadcast environment, you have 5 modes. If you are running OSPF in non-broadcast environment, you will have these 5 modes. But I just finished saying to you that these are all very old technology. Then why are we learning this 5 mode? Did you understand my question? Frame relay, ATM, X.25. When you use any one of this, we call it as non-broadcast multi-access. Only when you have non-broadcast multi-access with the OSPF, you have this 5 mode. Now, why are we learning this? If frame relay don't exist in today's network, then why are we learning this? We learn this to understand this 5 modes so that if in case you need any one of this in Ethernet environment, you can have it. I want to repeat. This 5 mode you learn using this frame relay because that is what a non-broadcast environment. And you will know the difference between these 5 modes once you finish learning. After learning this 5 mode, if you feel that I want my Ethernet broadcast to have the experience of non-broadcast multi-access, you can have it. So people who work very hard always, who always plan things beforehand and they get used to that planning, executing, and even after they get settled very well and they have enough, they won't stop it. They won't stop it because they're used to getting up early in the morning, uh, doing things. Though there are a lot of people now to help, they don't depend on them because they got used to that routine job for many years. But now they don't need that. They have everything in place. Earlier, there may not be a washing machine. They got a washing machine now. Earlier, no dishwashers. Now you have dishwasher. Earlier, you were not having four-wheeler. Now you have four-wheeler. You have everything. But still, those days practice. You continue in an Ethernet environment, broadcast environment. Broadcast environment doesn't need that non-broadcast behavior. Non-broadcast behavior has become practice and you continue doing even in broadcast modes. That's what I'm trying to say. Once you learn this five mode, how they behave, in what way one mode is different from another mode. After learning this five mode, you may feel that one of this mode will suit your broadcast environment and you can achieve it. Broadcast environmentல சகஜமா எப்பயோ நடக்கிறது உங்களுக்கு பிடிக்கல. நான் ப்ராட்காஸ்ட் மல்டி ஆக்சஸ் என்விரான்மெண்ட்ல இருக்கிற அந்த அஞ்சு மோட்ல ஏதோ ஒன்று வந்து உங்களுக்கு ரொம்ப பிடிச்சிருக்குது. அது இந்த ப்ராட்காஸ்ட் என்விரான்மெண்ட்ல இருந்தா நல்லா இருக்குமே நினைக்கிறவங்களுக்கு இந்த ஃபைவ் மோடு தெரிஞ்சிருக்கிறது நல்லது. இதுல இருக்கிற ஒரு மோடை வந்து பயன்படுத்திக்கலாம். Even though you have a broadcast mode, your OSPF will behave as if it behaves in a non-broadcast environment because you choose one of this mode. For this reason only we learn it. If you wish to have a non-broadcast experience in a broadcast environment, then you can adapt it, you can have it because you have experienced that five mode. You can bring it to your broadcast environment. Okay, so this is normal PPP, point-to-point protocol, or HTLC protocol you're running. This is not frame relay, this is not non-broadcast. This is simple WAN link, serial link. You may have a physical point-to-point and you may have sub-interface. We'll focus on this non-broadcast later. Now I'm just focusing only on the normal serial link. Will there be a DRBDR? No. In serial, there is no need for DRBDR. And then you no need to mention that network type as point-to-point. You no need to mention it. OSP will automatically take it as point-to-point. Have I shown this to you? Network type point-to-point under interface. Have I shown it to you? No? All right. So this topology, if you see this side of router 2, it will show you point-to-point. And this side, it will show you broadcast. Let's see that. Okay. Show IP OSPF interface serial /0. If you see here, it says network type as point-to-point. When you go to the other end, sorry, fast internet. This will show you broadcast. It is auto detected. I did not configure it. That is what it means, auto detect there. Hmm? OSPF auto detects this interface type. In another word, I can say this is the default interface type. This is the default network type on serial links. Default OSPF network type. And you need only one multicast address because there is no DRBDR. You need only 224.0.0.5 to communicate. Now this is Ethernet. This is Ethernet switching. This is circuit switching or point to point. In Ethernet environment, there will be a DRBDR. Don't worry about token ring. That is also very old technology. I heard in my life only once one guy was saying we use token ring in our office. Last 19 years. And frame relay also only two companies in last 19 years. One is Tata Teleservice in Hyderabad, another one is Etisalat in Egypt. So this token ring, it's olden days technology. Whether you have token ring or Ethernet, you will have DRBDR because it's LAN, and there are two multicast address. The information to DR is using 224.0.0.6, and information from DR to all other routers is sent using 224.0.0.5. We have spoken this in the previous class as well, right? Okay. But it was different page, different picture, same. We are in network type class. We have learned point to point, and we have learned broadcast. Now, how this DR/BDR is elected in broadcast, in this Ethernet switching, in this broadcast network type, the hello packets will carry the priority. The default priority is 1. If all have got same priority 1, priority 1, priority 1, priority 1, priority 1, the default priority is 1. See, on the other end, you may have different priority, that is different matter. The election is for each land. This is one land segment. There will be one DR and one BDR. Between this, there is going to be another election. This is another land. So for each land segment, there is going to be separate DR, BDR, and priority is interface level parameter. It's interface level, not the entire router. Each interface can be configured with different priority. But the default priority is 0. If the priority is high, if we set priority higher, you can set any number between 2 to 255. The number 1 is default. You can also set 0 or 1 to 0. 1 is already there. If you want to change to 0, you can change 0 like this, or you can set any number between 2 to 255 like this. So when we set priority, the router with the high priority becomes the designated router. But this needs to be done right in the very first time. Before OSPF starts sending hello to anyone, you should have said this. After they share hellos, after they form neighbor, if you change the priority, that is not going to change the role. You need to wait for OSPF reset. So if you are planning to make one particular router as a DR by setting priority, you need to do it as a first configuration before you configure anything else on the router. Not only that, before you go to other routers, you first finish configuring the DR. So start from this router, configure this router first, finish completely, then you go and configure this, then you go to these routers. Then only you will have that as per the priority. You want this to be DR, but what happened is you configured this one first, and then you configured this one, and when these two are talking and electing DR and BDR, there was no one else. So this says, I will be DR and you will be BDR, you know. So this says I'm DR because my router ID is this. This says, okay, I'll be BDR because mine is smaller. They already now finished the election process. Now you configure this and then you configure this and then you configure this. Will it form any change? Will it cause any change in this? No, there won't be any change. This all will this three will become DR other only. Because we learned that DR BDR is non-preemptive. You can see even here the last line. DR election is non-preemptive. So the priority matters. When you want a particular router to be a DR, first finish configuring that router, and then the BDR router, and then the other routers. The router with the highest priority is selected as the DR. The router with the second highest priority value becomes the BDR. And what is the tiebreaker? If there is a tie in priority, the tiebreaker is router ID. The one with the bigger router ID becomes the DR. This is the command to change the priority. You see, don't try configuring this command on a serial link. If you configure, it will accept it, but it won't make any difference. Because in serial link, there is no DR BDR election. There is no DR BDR election in serial link. So there is no use of changing priority. But in the Ethernet link, priorities are advertised in the hello packet. Now I'm going to capture a packet here. Now you will start seeing OSPF hello over the serial link. Yeah, this is a hello packet coming from router 1. And when I open this, it's hello packet type 1, packet type 1, which we learned early 5 types. And you see router ID. You see all these things. Again, I open this. You see, there is a router priority, but this is not OSPF priority. Let me show you the actual priority of the serial wire. That's router priority, that's not OSPF. Go to command line and see this show IP OSPF interface serial /0. You will not see anything like priority here. There is no mention about priority. You don't have any priority. But if you see a packet between this route 2, this is the second capture. If you see here, this is having high priority, but this priority has got a value. That priority, serial link never cares about priority. Let me show you this 255 on the command line. Here you don't see anything mentioned about priority in the serial link. Let's go to route 2. Show IP OSPF interface serial /0. Oh no, serial you won't have. I need to show what? Ethernet. Fast Ethernet 00. You will find priority here. This is the priority you saw there in the capture. I have set to 255. I'm going to change it, you see. Interface F00. IP OSPF priority. I'm going to say 10. I've set 10. Now let's go and see. I should see the 10 here instead of 255. And let me show it in the capture. You see the priority is now 250, not 255, 10. The priority is changed. Now this is on the broadcast link, on the Ethernet link. Now, whereas this one is on the serial link. Though you see the priority here, the priority is not focused. You see, show IP OSPF neighbor. What is the priority? 0. It says router 2's priority is 0. Wireshark says, let me take the hello packet coming from router 2. Wireshark says 1 here. Wireshark says 1 here, but serial link never takes that priority, never copies that, never considers that. It still says my neighbor priority is 0. I'm showing exactly the same thing. See the neighbor ID 2222. See the Wireshark from where it is coming. It's coming from 2222. Though the hello packet is having that priority 1, that is not really considered because there is no DR-BDR election needed in serial link. So OSP won't care about that priority. It will simply take it as 0 only. Only the Ethernet links priority matters. You saw even on the serial port, there is no mention about priority. Okay. The default priority is 1. The priority ranges from 0 to 255. If you put a router with a priority 0, it means that the router should not participate in election. If you wish a router not to be a DR-BDR, if you want a router not to become a DR or BDR, just set the priority to 0. That will always remain DR other. So this router C here in this example will always be a DR other. A router that is not a DR or BDR is called as DR other. Is there any question so far? No. Okay. So we have seen in depth these two types which we have done some labs, point to point and broadcast. In point to point, the default priority is 0. And even if you change the priority, it is of no use. I showed you why it is no use. It won't even consider priority. So there is no use of changing. There is no DRBDR. In a broadcast environment, which is also called as Ethernet switching, there will be a DRBDR election. So priority matters. If priority is a type, router ID matters. So this 5 mode is what going to be totally new for us. I'm going to use frame relay to explain you, to give you a very clear picture. But the frame relay is not in industry. So whatever the level that you understand it, the frame relay part, that is more than enough for you. Just focus only on the OSPF part, which is going to operate on top of frame relay, because frame relay is a packet switching encapsulation. We just take the packet, layer 3 packet, and we encapsulate with frame relay DLC numbers, and we are going to switch the packet. It's packet switching. It's non-broadcast multi-access environment, NBMA environment. So in this environment, NBMA environment, we will have this 5 modes. Number 1, non-broadcast. Another one, point to multi-point. These two are RFC standard mode, NBMA network type, RFC standard network types. The other 3 are Cisco standard network types. Point to multi-point, non-broadcast. And this broadcast and point to point is not the same broadcast and point to point which we saw today. This broadcast and this point to point is coming under what? Non-broadcast. See, we are learning this 5 mode so that we can have any one of this mode in an Ethernet environment, which is there in today's world. Same way. During those frame relay days, if they wish to have a broadcast feeling, broadcast experience in a non-broadcast environment, they used to have this mode. You understood that? So, even though you have a non-broadcast environment, you will get the output as you get in a normal Ethernet environment and normal PPP or HDLC environment. So anyway, we are going to go in detail later. These are the 5 mode or 5 network types under NBMA. Non-broadcast, point to multipoint, point to multipoint non-broadcast, broadcast, and point to point. For this, what is needed? Frame relay is needed in the middle. You see these clouds? This cloud represents frame relay. Now, during those frame relay days, seeing a topology like this is very rare. Very rare. Not that very costly. It's very costly. Not that easy to see full mesh topology. You see, each site is connected to all other sites, which is very costly. Why? Because this is one frame relay PVC. You need to pay This is another PVC, another PVC, another private virtual circuit, another PVC, another private virtual circuit. Very costly. So usually we will have a partial mesh. You see, not every router is connected to all other. This is only connected to these two. Now this is full. This is hub and spoke. This is what we used to have in frame relay. This is cost effective. Full mesh is very rare.